Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 4 of a unit motion in a plane. So let's begin with today's class. Today we are going to discuss about the vectors. It's a part 4 and last session of a vectors. And today we are going to discuss about the multiplication of the vectors. We have done with the addition, we have done with the subtraction, and now it's a time for multiplication of vectors. So let's begin then. That suppose when we multiply two vectors, it's a multiplication of vectors. When we multiply two vectors, I could have two answers or two different answers. One is the scalar vector, one is the what we can say it's a scalar multiplication, and another is the vector multiplication. So when I say scalar multiplication, I mean my answer would be scalar. And when I say vector multiplication, I mean my answer should be vector. Is it clear? Now, when to perform scalar multiplication, when to perform vector multiplication, that I will let you know as we proceed through the lecture. Yes, but there are two kind of multiplication is possible on the vectors. One is the scalar multiplication, another is the vector multiplication. Even the scalar multiplication is also said as the dot product, and this vector multiplication is considered as a cross product. So one is the dot, another is the cross product. Yes, scalar multiplication is a dot product and vector multiplication is a cross product. Yes, so let's begin then with the dot product or scalar multiplication. So dot product or scalar multiplication. So suppose we have this vector A as AXI cap plus AYJ cap plus AZK cap. We have one more vector B, it is a BXI cap plus BYJ cap plus BZK cap. You must remember this formula that it is an A dot B, that would be equals to A B cos theta. This A dot B and this is equals to AB cos theta. This represents that this is having a dot product between this vector A and vector B, while theta is the it is an angle between vector A and vector B. It's an angle between vector A and B. So this is A dot B is equals to AB cos theta. I hope you remember understood this. Do you? So shall I move ahead? Yes. So let's begin then. That my vector A was the AXI plus AYJ plus AZK, and vector B will be BXI plus BYJ plus BZK. This is the situation, and what I need to do, I need to perform A dot B. It's a dot product, that means it's the final answer would be a scalar one. So if I multiply this, if I need to multiply this, what I can have is AXI plus AYJ plus AZK dot, that means multiplied with BXI plus BYJ plus bzk cap. Yes. So now what I need to do is I need to multiply 1 multiplied by with this. So that should be represented as axi into bxi cap. This is axi into bxi. So now what was my answer? That should be clear in your, that should be clear in your back of the mind, that my formula was a dot b, and that would be is equals to a into b into cos theta. That must be clear in back of the mind. So what you know is this is the theta, theta is the angle. So if you look at this, this is I cap, that means in x direction. This is even I cap, that means it is in x direction. So if this two are in x direction, this two are in x direction, that means, that means your final answer would be, your final answer would be equals to ax into px. I hope you understand this. Now you need to multiply this ax with the by. So this is equals to ax I cap multiplied by by j cap. So as you can see, this is I, this is j, this is I, this is j. This theta is the 90 degree, and cos 90 would be 0. So this is 0. Yes. Same way you are going to do with this. It's an axi into bzk cap. So again this is I, this is k, so this is x, this is z. So again angle is a 90 degree, again angle is a 90 degree, so it would be a 0. Yes. Now 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 next it's the turn for the j cap. So it would be an ayj cap dot bxi cap. Again this is j cap, this is I cap. So j dot I, j dot I, that means angle is 90, and angle is 90, that means 0. Now it's a turn, now it's a turn for the ayj and byj. It's ayj cap into byj cap. Again this is j cap, this is j cap, that means both are in y direction. So this will be ay into by. Now I hope you remember this and you understand this as well, that this is j, this is k. Next turn, this two having an angle of 90 degrees, so it would be a 0. Now it's a turn for azk, azk. So what it would be, it's an azk, this is bxi cap. So this k and I again 90 degree, this would be a 0. K and j again 0. Then k and k, yes, it is having an angle of 0 degree, and as angle of 0 degree, it's in cos 0 1. So this would be is equals to az bz. Yes. Do you understand this? Do you? So if on a summary note, if I want to write like this, it's an a is equals to axi cap plus ayj cap plus azk cap, and vector b is something like bxi cap plus byj cap plus bzk cap. And let's say I have been asked that find out c is equals to a dot b. Look at this, having no vector sign, that means this is the scalar product, this is the scalar product. What you need to do is you need to just multiply coefficient of I cap with other coefficient of I cap. That means I multiplied with the I, j multiplied with j, k multiplied with k, but with sign. So here in this case I multiplied with I, that means it is an ax bx plus here this is ay, this is by, so that would be equals to ay by plus this is az and this is bz, so this is az into bz, this is equals to c. So this is ax bx plus ay by plus az bz, this is the dot product, this is the dot product. Is it clear? Is it? So can you do it? It is very easy, very easy, that you need to just simply multiply this. While multiplying you need to taken into consideration that I must be multiplied with I, j with the j, and k with the k. That's it, and things will be done. So let's have a look. The question is given that, the question is given that suppose vector a is 4i minus of 2j plus 3k, and vector b and vector B is 2i plus 4j minus of 4k. Find find C, which should be A dot B. Yes, this is the given data. Now I know that I need to perform a dot product, and if I need to perform the dot product, C is equals to A dot B. What I need to do is I need to just multiply the coefficients of I. It's a 4 into 2. Now with sign plus, this is minus of 2, j multiplied by with the j, plus this is 3, this is minus of 4, plus 3 into minus of 4. Yes, so this is 4 2s are 8, minus 2 4s are minus of 8, 3 into minus 4, it's a minus of 12. This 8 had gone and the term that remain is minus of 12. That's it, you did it. Is it clear? Is it is it clear? Yes. Can you do it? Can you do this? Are you sure? Can it be done? Can be? Yes. Let's have one more question. If force acting on an object is F is equals to 4i minus of 2j plus 3k, and they say displacement due to this force, displacement due to this force is 2i plus 4j minus of 2k. Find out work done. This is the requirement. So first you must consider that do I have any formula that can relate work done, force and displacement? Do I have anything? Do I have anything? Yes, so I must know that yes, I am having a formula that work done is equals to force into displacement. Now you need to consider that whether work done is scalar or vector. It's a scalar or it's a vector. So if you remember your ninth class, you must know this. Even in the scalar vector discussion of previous slides, yes, we have discussed that work done is a scalar one, and as it is a scalar one, vector option has been closed. So what I need to do is, and what I understood is that this is the first vector, it's a force. This is the second vector, it's a displacement, and I need to multiply this two such that I could have a scalar answer. So if I required a scalar answer, I must perform dot product on these two vectors. So let's do it. That my force is given as 4i minus of 2j plus 3k. My displacement, let's denote it as an x, that it is a 2i cap plus 4j cap minus of 2k cap, and work done, the work done should be is equals to force dot displacement. That work done is equals to force dot displacement. I hope you understand why I have chosen the dot product, because my required quantity would be the work done. Yes, so if it is in work done is a scalar or vector? Yes, it's a scalar quantity, and as it is a scalar quantity, I need to perform a dot product on this too. So let's do this. It's a 4 2s are 8, minus 2 4s are minus of 8, 3 2s are minus of 6, because it is minus 2. This 8 has been gone, and this is minus of 6 joule. That's it, you did it. Well done, guys. I hope you understand this too. Is it any confusion? Any confusion, any query? No? So can we move to the next? Can we move to the next question? Are you ready for this? Let's have a look. That if they said that vector A is 4i plus 2j plus xk, and vector B is 2i minus of 6j plus 4k. They said if vector A is perpendicular to vector B, then find out x. This is the requirement. They say that if A is perpendicular to B, then you need to find out the value of an x. Now how can you do this? What can you do? Yes, what I know is that C is equals to A dot B, and this would be is equals to, this would be equals to A B cos theta, as they have mentioned that A is perpendicular to B. So if I perform A dot B, that means 4 into 2, this is 8, 2 into minus 6, this is minus of 12, plus 4 into x, this is 4x. That should be is equals to A into B into cos of perpendicular, they are the 90 degree. As they are on the 90 degree, this cos 90 would be 0, and this has been converted to 0. So the term that remains is 8 minus 12, this is minus of 4 plus 4x. So if I solve this, it's 4x is equals to 4, and this should be x is equals to 1. This is my answer. So when they said that these two vectors are perpendicular to each other, our mind must attend it such that shall I do this with the dot product so that my task can be done. You must consider that, and you must at a very first attempt you must think this, that if I do the dot product, this can be converted to a 0. That means AB cos theta converted could be a 0, and as they are converted to 0, I can solve the remaining terms. I hope this is clear. So can you do this now? Can you do this on your own? Are you sure? So are you comfortable with this? Are you comfortable with the dot product of the vectors? So shall we switch on to the cross product? Shall we? So let's begin then. The cross product, or we can say it's an vector multiplication of two vectors. Cross product, it's an vector multiplication of two vectors. So let's say, suppose vector a1, it's an a1i plus a2j cap plus a3k cap. Vector b, it's a b1i cap plus b2j cap plus b3k cap. Yes, this is the vector a, this is the vector b, and suppose I need to perform a vector c. Look at this sign, and this requires an a cross b. This represents the cross product. So at a very first thing you must remember that a cross b, a cross b is equals to a b sine theta. But as this is the vector product, this must be a vector, so we add one unit vector. This is ab sine theta into n. This is a into b into sine theta into n cap. Yes. So what we need to do is that, suppose let's say this is a cross b, and I need to perform a b sine theta n cap. My vector a was the a1 I cap plus a2 j cap plus a3 k cap. Vector b would be equals to b1 I cap plus b2 j cap plus b3 k cap. So, and I need to find out a cross b, that is vector c. So what you need to do is that this is vector c, or I can say vector of magnitude of vector c. First row contains I, j and k. First row contains I and j and k. Now as you want to perform a cross b, so first it's an a vector. So first you need to write down the coefficients of the a vector. That means I'm talking about the coefficients of I and j and k. It's an a1, a2, a3. Now it's an a cross b, that means the vector number b. It's a b1, b2 and b3. Yes, so that should be. How should I do this? How should I do this? Probably the maths people know this using the method of determinants, but the medical students might not get it. Yes, so for this two peoples, what you need to do is you need to simply write down the I cap. You need to simply write down the I cap, and then please remember this, that you need to please forget this and this. So what is left? The left term is a2, b2, a3, b3. Now cross multiply this, so it would be an a2 into b3 minus of b2 into a3. Is it clear? Next would be the minus of j cap, minus of j cap. Yes, it comes with the minus. Now what you need to do is, you need to forget this and this. So whatever the left term, it's an a1, b1, a3, b3. So it would be an a1 into b3 minus of b1 into a3. Yes, this is the second term. And the last, it is the plus k cap, and that can be calculated based on that. You need to forget this and forget this. So whatever the left is a1, b1, a2, b2. So this is equals to a1 into b2 minus of b1 into a2. Yes, this is the vector c. This will give me a vector c. Yes, I hope you do this, or you can do this. Yes, how this has been arise? This is with the same situation AB sin theta that we have performed in the dot product, that first a1i b1i, then a1i b2j, then a1i b3k. But in the dot product there was an cos theta, and cos 0 is 1, but here it is a sin theta, and sin 0 is 0, but sin 90 is 1. Yes, only that major changes would be there. And if you again rearrange this multiplication, you are going to have this. So we are not going to multiply this one by one, but we are always using this methodology, that first, let's say suppose it is an vector product of p cross q. Then first I need to, on a very first column of that determinants, I need to write it's an I j k. Then as it is a p cross q, that means I need to write down the coefficients of I j k of the vector p. Then I need to write down the coefficients of the vector coefficients of the ijk from the vector q, and then I need to multiply the p cross q. How? Then so let's begin with the I. You need to forget the column where I has been written. You need to forget the column where row and column both where I has written, and then you need to perform the cross multiplication. So as soon as you are moving, the things will be done. Only one more thing is to be remember is that I would be positive, k would be positive, but j would be always comes with the negative. It's a minus j multiplied by cross product of them. So can it be done? Can it be done? Yes. Are you sure? Are you sure with this? Can we do this? So let's have a look. One more thing I want to focus is that, let's say this is the I cap, this is the j cap, and this is the k cap. Yes, this is the ijk, as you will know that I cap represents the x, j cap represents the y and k cap represents the z. If I suppose to move in anti-clockwise direction, that means from I to j, from I cross j, it would be an k cap. If I move again in this direction, it's an j cross I, j cross k, it would be an I cap. If I move from k to I, if I move a k cross I, that would be a j cap. This is the situation when we are moving. This is the situation when we are moving in anti-clockwise. Now, if we are moving in clockwise direction, if let's say if we are moving in the clockwise direction, something like this, it's in j cross I, then it would be equals to minus of k. Let's say it's in I cross k, this is equals to minus of j, something like this. Let's say it is in k cross j, it would be minus of I. This is the case of clockwise. So again go through it and observe it. If you observe this very carefully, your mind should strike at some place that if I cross product this a component in x and component in y, then I get an answer in component in z. And this is true for every case. Let's say this, if I multiply according to the vector product a component in y direction and component in z direction, then I get an answer in component in x direction. If I multiply this in component in z direction, component in x direction, then I get an answer in component in y direction. So please remember that my that answer of vector multiplication is always perpendicular to both of its vectors. This is true for every time. So let's say suppose I need to perform C is equals to A cross B, then I must know that my vector C must be perpendicular to vector A, my vector C must be perpendicular to B. This is the always the case. This case would be always true, that when I multiplied I and j, my answer would be k. Yes, it could be a plus k, it could be minus of k, depends that whether it is an I cross j or j cross I. But that is for sure that if I multiply a component in x direction with component in y direction according to the vector product, then I must get my answer in the z direction. It could be plus z, it could be minus z, but it would be in z. It could not be in x, it could not be in y. I hope those things are clear. Is it? So shall we practice the same? Shall we? Let's do it quickly because time is running. Yes. So this is vector A, this is equals to 2i plus 3j plus 4k, and this is the vector B, it's in 4i plus 2j plus 3k, and I need to perform C, which is give me a C is equals to A cross B. So if it is C, which can be calculated as A cross B, what I can have is I can simply write it since C is equals to first line, it's an I comma j comma k, it's an ijk. Yes, now you need to perform A cross B, so take in coefficients of the A first, it's a 2 comma 3 comma 4, then from the B it's a 4 comma 2 comma 3. Now what you need to do is you need to just simply multiply it. But how? Then that for I you need to forget this and you need to forget this. Now have a cross multiplication of this. This is 3 3s are 9, minus of 2 4s are 8. I hope you can do it. Yes. Then minus of j, forget this and forget this. What else remains? It's a 2 3s are 6, it's a 2 into 3 minus of 4 into 4. then then you need to write it as in plus k. So this is equals to 2 into 2 minus of 4 into 3. So this should be is equals to, this is 9, this is 8, so it's a 1. It's an I cap minus of j into bracket 2 3s are 6 minus 6 4 4s are 16. So this is minus of j 6 minus of 16, it's a minus of 10 plus k cap. It would be a 2 2s are 4 minus 12, this is minus of 8. So that should be is equals to I plus minus minus plus, it's an 10j minus of 8k. This is the vector C. That's it. What was your answer? Is it the same? Does it? Does it same? Are you sure? Great, good work. So one more. Shall we move through this? Let's do it. This is vector A. This would be equals to 2i minus of 4j plus 3k. Another is the vector B. Another is the vector B, which will give me a 4i plus 2j plus 4k, and I need to multiply this. This is C is equals to A cross B. Now what you need to do is you just pause the video. You just pause the video, calculate it, and again play it. Yes. So let's begin then. Let's begin with first, it's an I cap, J cap, K cap. Vector A, it's a 2 minus of 4 plus 3. Vector B, it's a 4 2 plus 4. So now it would be I multiplied by this 2 needs to be forget. It's an, so what you need to do is minus 4 into 4, it's a minus of 16. 3 2s are 6, but here it would be a minus of 6. Now it would be a minus of j, so you need to ignore this 2. That's a 2 4s are 8 minus of 4 3s are 12 plus k. Omit this. It's a 2 2s are 4. It's a 2 2s are 4 minus minus plus. So this is 4 4s are 16. So the term would be minus of 16 minus of 6. What is it? Minus of 16 minus of 6. It's a minus of 22 I cap. 8 minus 12, it's a minus 4, minus minus plus 4, it's a plus 4j. It's a 4 and 16, it's a plus 20 k cap. This is the final vector. This is the final vector C. So can you do this? Can you do this kind of question? Will you be able to solve this? Are you sure? Are you sure? Yes. So let's check it out. Very good application, very good application of dot product and cross product as in combined. That suppose they said that find out value of A cross B dot B or A cross B dot A, and your A and B has been given. That A would be is equals to, let's say, 2i cap plus 4j cap minus of 3k cap, and vector B would be equals to, let's say, 4i cap plus 3j cap plus 2k cap. Now you need to do this. It's an A cross B dot B or A cross B dot A. So at a very first approach, what you think is that what I need to do, I need to just simply, let's say, suppose if I have picked this question, then what I need to do is, this is A cross B, then I will perform this I J K and something like this, and whatever this answer comes, this answer dot product of B, this is the, let's say, vector C, and then vector C, and this vector is B. Yes, this approach can work. It is absolutely okay. Done with this, and no any issues would be there. But if you think this more logically, can you see something else also, so that this can be done within seconds? Can it be done? Please look it very carefully. This approach, whatever this approach is correct, and I don't mind if you are using this as well. But can you see something else? Anybody? No? So let me give you an hint. Suppose I need to perform A cross B dot B. Suppose answer of this is C. So I need to perform C dot B. Now, now, do you remember that this C must be that answer of the any cross product C must be perpendicular to vector A and vector B. Yes, whatever the answer of C would be, it must be perpendicular to A as well as B. So if you are going to perform C dot B, it comes to an end at a CB cos 90 degree, because they are perpendicular to each other. And if these two are perpendicular to each other, that means cos 90 would convert my answer to a 0. It's a null vector. So no need to do even this kind of thing, that first perform A cross B, then answer would be there, then whatever the answer would be, you need to perform a dot product of this. No, that is not required at all, because you can simply know this, that if I perform A cross B, then my answer, whatever the answer could be, it must be perpendicular to A and B both. And if it is perpendicular to both A and B, then then I must know that then I must know that if I perform the C with the dot product of B, then it would be a CB cos 90, and that would be a 0 null vector. Yes, even it is the case with same case with the B as well. Suppose it is an A cross B dot vector A. So this would be a vector C dot vector A. As I know, C must be perpendicular to A and B. Yes, this vector C must be perpendicular to A and B. So if I multiply this, it's a C dot A, which will give me a CA cos of 90 degree. And as it is a CA cos 90 degree, it would be a 0, which will give me a null vector. I hope this is clear. Is it? Is it clear? So can you do this? Is it possible by you guys? Are you sure? So I hope multiplication of two vectors can be done by you. Yes. So one is the dot product, another is the cross product. Dot product will help me when I require an answer in a scalar terms. How I consider that, should I require an scalar or vector, that will be dependent by the quantities. That suppose torque has been asked and you have been given the force and the displacement, then you must know that torque is a vector quantity. So if torque is the vector quantity and that is required from the force and displacement, which two are the vectors only, then to get a vector quantity I must perform vector production of force and the displacement. That is what I know. Yes, and if I know that only, then I can have a decision that yes, I am going to go with the vector product. Then it's an torque equals to r cross f. That relation you will learn in the uh, coming units, and then you can do this easily. So I hope this is clear. I hope these things are clear to you. Is it? Is it? Any issues with this? Any issues with this? No? Okay. So let's move to the two very important concepts of the vectors. Our first one is the Lamis theorem. Lamis theorem. Yes. What they says that if three coplanar forces are acting at a point, are in equilibrium now. Do you understand this? Do you understand equilibrium? So what the equilibrium is, what we can know about the equilibrium is that net force acting on a point is zero. It's an equilibrium. Yes. So if three coplanar forces acting at a point, they are in equilibrium, then each force is proportional to the sine of the angle between the other two forces. So, so if you, this is the statement. But if you want to write the things, if you want to write the things, let's have one more trick. What you are going to write is that this is force F1. That F1 should be divided by a certain angle of sine which F1 has not produced. Please, I'm going to repeat this. Look at this very carefully. That you are going to divide this force F1 by a certain vector of, by a certain angle of sine. That angle should not be produced by F1. So if that vector has not been produced, if that vector should not be produced by F1, that angle has not been produced by F1, then that angle must be produced by F2 and F3. Which is that? It's an alpha. So you are going to write this as an F1 divided by sine alpha. I hope these things are clear to you. Same way, for F2, that must be divided. F2 must be divided by sine of that angle that has not been produced by F2. So it is an F2 divided by sine B. I hope this is clear. Same thing is true for the F3 as well, that F3 needs to be divided by some sine of angle that F3 has not produced. It's a gamma. So this is F3 by sine gamma, and things has been done. Yes. So this is F1 by sine alpha is equals to F2 by sine beta, and that would be equals to F3 by sine gamma. Yes. So can you do this? Can you do this? Are you sure? Are you sure? Okay. Let's first have a look of one of the question of this. Let's have a look one of the question of this, and then we will come back to the directions of the cosines. Let's say situation is something like this, that here one of the block is there and it has been tied with this wall with the help of certain string. This point has been tied at this point, probably a ceiling. Yes. And here one of the forces is acting, this is mg. Yes. And they said that, let's say here one of the forces in string would be developed that we call as a tension force. This is the T2 force, that is the tension 2. And let's say that this is suppose 30 degree that they have given. Yes. So what they ask is that mass of a block is 10 kg and it is in equilibrium. It is in equilibrium. Find out T1 and T2. Yes, I know that at this point of time you don't know how the tension would act and something like this, but think according to the only the vectors. This is the question of vectors only. We are not going to discuss anything about the tension forces. So if I consider this as a vectors only, what I need to do is look at this. They said it is in equilibrium, that means this three are the equal. Yes, this or the resultant of this 3 would be a zero force. So this is 30 degree, as I can say this is 90 degree. Yes, so this is 30 plus 90, 120. This is already 90 that I can see. Yes, so 30 plus 90, 120, 120 plus 90, it's a 300, it's a 210. So this force must be a 150 degree. This angle must be at 150 degree. Now, now you have three forces. It's a T1, T2 and mg. You are also having the angle between this three. So what you can write is we are not going to solve this here, but I want that you people must know that what can be written according to the Lam's theorem. So what I can have is that T1 divided by angle of that sine that has not been produced by T1. So this is it, angle of 120 degree. So T1 by sine of 120 degree, that must be is equals to T2 divided by angle of that sine that has not been produced by the T2. So what it would be? It's a 90 degree. So this is T2 divided by sine of 90 degree, and that would be equals to mg divided by angle of that sine. Angle of that sine that has not been produced by mg, it's in 150 degree. So if I know the value of sine 120, sine 90 and sine 150, this can be done easily. At this point of time we are not going to solve this, but this can be done. This is very easy according to the Lamis theorem. Yes, yes. So can you do this? Can you do this? Okay, great. So let's come back to the directions cosine. Yes, we say that the directions cosines that we denote is an L, M and N of a vectors are the cosines of the angles. The angles are alpha, beta and gamma, which a given vector makes with x-axis, y-axis and z-axis respectively. If this is the situation, then let me look this. It's an x, it's an y, it's an z. Yes, this is the resulting vector. This is the resulting vector, vector A, and I have made an this vector A, this resulting vector A has make an angle of alpha with the x-axis. It has make an angle of gamma with the z-axis, and it has made an angle of beta with the with the y cap, or with the y-axis it is a j cap. So if I write this from here, it's an cos alpha. If you need an help, I can do this. It's an ax and this is a. So if I write this cos alpha, it is an ax by a. I hope these things are clear to now. It's a cos beta would be a ay by a. It's a cos gamma would be an az by a. So if I just add this by squaring, it's an cos square alpha plus cos square beta plus cos square gamma. This would be ax square by a square plus ay square by a square plus az square by a square, and this would be equals to ax square plus ay square plus az square. Now what is a? My a was, it's an ax I cap plus ay j cap plus az k cap. So if I make a square of this, a square, it's an ax square plus ay square plus az square. Yes, so it is an ax square plus ay square plus az square divided by a square. So it's a square by a square. This is equals to 1. So this cos square alpha plus cos square beta plus cos square gamma is equals to 1. And if I find it out, the value of sine square alpha plus sine square beta plus sine square gamma, how it could be done? It's a replace just cos square alpha with 1 minus sine square alpha, replace cos square beta with the 1 minus sine square beta, and replace the cos square gamma with 1 minus sine square gamma. Then you can have this sine square alpha plus sine square beta plus sine square gamma, it is equals to 2. So please remember this. At in one of the examinations this has been asked, value of sine square alpha plus sine square beta plus sine square gamma. Yes, so let's wind it out here. In this session we have been discussed that how two vectors can be multiplied according to the dot, according to the cross, then Lamis theorem, and this directions of cosines. So this is all about vectors. We are not going to learn anything other than this in the vectors. And why? Because that is not required by physics at all. So please practice a lot. This will help us not only in 11th, in 12th as well. And in the next session we are going to start with the projectile motion. Yes, but before you tune to the next question, please do as many questions as possible. Yes, thank you. Have a good day. Take care.